Hello, my name is Beth Dixon. I am the Math Lab Coordinator and work in MBSS 222 in the Math and Behavioral Social Science building. It is my job to help students through their math courses here at Walter State Community College. And this is the part 2 of a lesson on standard normal curve. Part 1 consisted of telling you how to work the table and doing the 3 basic things that we do with the table, which is finding area to the left, finding the probability and area greater than, and finding area and probability of areas between. There is really one other slight thing that we do, but really it's not anything other than combining one of the other methods. But our new text will do that, and you may see it as we do some later things. So I did want to cover it as well, and that's really an or statement. And we kind of do it a little bit as we do some other things in our class in the spring of 2010. So I'm going to kind of cover it. If you don't see these problems, don't worry about it. If you do see these problems, great. And then I'm going to talk about how to do the inverse norm, which we will need to see for both the spring 2010 as well as for our later courses as well, or later as in time, not later as in additional statistics courses. Again, remember that as we do these problems, we are talking about the standard normal, where the mean is 0 and our standard deviation is 1. And as we're doing this one, we want to find the probability that z is less than negative 0.23. Well, since these are z-scores, that z tick mark right there would be 0 and be negative 1. So negative 0.23 would be really close, and we want it to be less than this, and it would shade all of this area here, or greater than 2.98. 1, 2, so greater than 2.98 would be this little tail right there. So we call that 2.98, and this mark right here, negative 0.23. Well, that means we need to look up both of these numbers. But notice this one is not a between, so we're not going to subtract these numbers from each other. Well, less than negative 2.3. So let me get out my table and my little helpmate here with my little straight edge, and I'm going to look up negative 0.2. That'll be this row right here, and then the 3, which I'm coming down the 3 column, which is hard for me to show and keep my table straight, but coming down the 3 there. And that gives me 4090. So that tells me this area right here is 0.4090. I'm going to double check that number. Again, because I'm on tape and don't want to miss this, because I got dyslexic, and then y'all look it up and say, how did she get that number? That is correct. Okay, now the problem is that's not the only area. I have a little area out here on this tail as well. Well, this area is a greater than area. So to find it, I need to look up 2.98. Well, that comes down here to the 2.9, and then come over to the 8 column, and again come down the 8, and that gives me 9986. Well, the 9986 is over here, and I need this little bitty tail. So to find the tail, I need to do my complement, 1 minus 0.9986, which tells me my little tail right here is 0.0014. So this area right here and this area right here are both shaded. So to get the total area, I would just add 0.4090.0014, combining the two techniques that I know, and I get 0.4104. So it's not really a different technique in reading the table to get my answer. For this one, I use the area to the left. For this one, I use the area to the right. But to get my total area, I had to add both of those together. So just like when we did our probability section, the OR statement means to add. So we'll add the probability for this part to the probability we get for this part, and we add those two statements together. But it's not different for our table because there's still just three things we do to the table. Again, let's try one more example. We want the probability that z is less than negative 1.98. And again, these are our z-scores with the mean of 0 and a standard deviation of 1. And negative 1.98 is going to be right down here, very close to the 2. And it's going to be less than that. Or greater than 1.98, very close to the 2. And greater out in this direction. Now this one is what we would call symmetrical because it would be the same on both sides. And that may help us some in the table, but the procedure would be the same. We would look up both numbers. So I'm going to look up negative 1.9. Bring that down so you can see. There's the negative 1.9. Then I'm going to go over to the 8 column. Come down. And that gives me 0.0239. 0.0239. Notice the meticulous way I keep up with this with the pictures. The pictures are worth thousands of words, and you can keep up with your area by realizing that when you look up in the table, it always gives you an area to the left. Now, when I look up my positive 1.9, and then over to the 8 column, I get 9761. And again, that's the area to the left. And when I put that on here, that's going to be over here, 9761. It's not the tail that I want. So to get that, I need to go 1 minus 0.9761. 1 minus 0.9761. And guess what that gives me? That gives me that my little tail is 0.0239. Again, remember I said that my chart is symmetrical. So that would be the same on both sides. But I need parts here and here, this area and this area added together. So I need 0.0239 plus 0.0239. And I get 0.0478. And again, you want to make sure that your final answer is easy for your teacher to spot as your final answer because you do have a lot of numbers floating around there. So when you do an OR statement, remember your OR reminds you to add the two probabilities and that you want to be sure that your picture is helping you find these answers. It is very important that you use these pictures and draw these pictures from now to the end of the chapter, to the end of this semester, because every time you draw these pictures, you help yourself keep up with your information. Okay, now we also want to be able to go backwards. We have been given a Z every time and then looked inside the chart for the area. These problems also work in reverse, where we know the probability, but we don't know what the Z is. There's often problems where we know that we want to have a 95% probability of something happening, but we want to know then what that z-score or what that cutoff score would be. Such cases of these would be if we wanted to let only the top 10% of college students be in Who's Who. If we only wanted to admit, if an elite college only wanted to let the top 95% of students into their college. If UT only wants to let the top 60% of students scoring on the SAT or ACT students be admitted as freshmen, then they have a cutoff score for their ACT. They need to figure out what that cutoff score is. Those are all examples of where they know what percentage or probability, but they don't know what the cutoff score is. Now we're going to go back and do it for just the normal, standard normal here, where the mean is 0 and the standard deviation is 1, but then we'll go on to the next chapter where we have real examples and we can go a little bit further. But first, we're just going to, today, in this lesson, we're just working on how to read the chart and how to read the chart backwards. So these problems are my reverse problems. It's like, how do you drive in reverse? Well, the first thing you've got to do is be able to find numbers in this chart, which I'll admit is not my easiest task. Because of my eyesight, my age, and my astigmatism, I have difficulty doing that. So I'll also show you how to do some of it on the calculator, but I also show you how to then check that answer with your table, because I'm a firm believer that your calculator is not smart. Your calculator does not have a brain. So unless you check your answer on the chart, you're not sure that you didn't just type garbage into your calculator, because you're garbage in, garbage out. So let's look at an example. If we're given an area of 0.25, can we find the corresponding z-score? Okay, well, let's draw that. And in this case, what I had intended to mean is an area to the left. So we're just going to stick to an area to the left. So what we want is an area so that 0.25 is to the left. And I'm not sure where that falls. So I have no idea where that falls and if it's even going to be symmetrical when I draw it, if it's even going to be appropriate where to put that. But I'm just going to write 0.25 in my chart. And again, knowing that 0's there, the mean is 0, and the standard deviation is 1, because I'm dealing with the standard norm. But I do know I want to look up 0.25 not as a z-score, but as the area or probability in the middle of my chart. So what I do is come over to my chart, and I start looking for areas of 0.25. Now notice that all of mine have 4 decimal places. So really, instead of looking up 0.25, I'm looking up 0.2500. Okay, so although this says 0.0024, I need something that starts with 0.25. Well, that starts with 0.0, so I need to go way on down here. Well, that's 0.1, 0.2, 0.23, 0.26. I'm getting close. 0.24. 0.25 right there. 0.2514. Here we go. These two numbers right here, in between my arrow there, are the two closest values. Notice I do not have an exact value. We cannot find the exact value on this chart because this chart is rounded to 2 decimal places. All of our z-scores are always rounded to 2 decimal places because they had to decide how to do it, and this was the easiest way to do it. So we're going to choose the one closest. Well, 2514 from 2500. Well, let's just take that calculator out. 0.2500 minus 0.2514. Well, that's a difference of 14. Ignore the decimal places. It's just a difference of 14. And the other one is 0.2483 minus 2500. It's a difference of 17. Well, the closest one then is the 2514. That's the closest value. Well, what is the z-score that corresponds to that? Well, as I go up, I see that it's the 7. As I go out, I see that I'm at the 0.6, negative 0.6 on the row. So I was way over here too far because my z is negative 0.67. And I could put the 0 in front of it if I wanted to. So technically it should be about right there to put the area at 2500. But it doesn't have to be drawn to scale, and that's the z-score that corresponds to an area of 0.2500. Now, using the calculator, this is how you do it. You go second distribution, and you want to use the inverse norm. Remember I said this is driving in reverse, going in an inverse operation. So we want to do the inverse normal. And this is the standard normal. Okay, so we want to type in what area is to the left of our mark. Well, to the left of our mark is that 0.25. Our mean is 0, our standard deviation is 1, or we can just leave that off because the calculator will assume a standard normal. And notice it gives us that negative 0.67489. Well, the calculator gives us a more accurate answer, but we want it to the table value. So what it tells us is negative 0.674. So we would want to then take our straight edge here and check that we weren't going crazy, that we did everything right, and go to negative 6.7 and check the values close to it to make sure that that's the value closest, that we typed in their decimals right, and then we would know that we were using the correct value. Okay, now let's look at the second example I have here. It says, given the probability of the middle 95%, find the corresponding z-scores. And by this, what I mean is we want to put 95% in the middle of my chart. And again, this is not to scale, but we want 95% of the area in the middle. If we have 95% in the area in the middle, what percentage does that leave for each of the tails? Well, that's 100% total minus 95% gives us 5% left, which is 0.05 as a decimal, because remember, the table will be in decimals. Well, we want it strictly in the middle. We want it to be symmetrical. Since it's symmetrical, we want it divided evenly between the two tails. So that would be 0.05 divided by 2, which is 0.025 on either side. 0.025 on this side and 0.025 on that side. So we need to look up this time 0.0250. Same numbers, but notice the 0 makes a big difference here. So now we need to come up here and look up 0.025, and I'm going to search the chart out, and lo and behold, I find that number. I find it exactly this time, 0.0250. And it's at negative 1.96. I actually chose it because I knew it would be easy to find. It's one of those that's easy to find. Negative 1.96. Now to find this one on this side, it's actually going to be pretty easy because it's symmetrical. We can know that it's going to be a positive 1.96 because we have that symmetry. But if we look it up in the table, we can't look up positive. We can't look up 95. We've got to look up all the area to the left. So it would not be 95. It would be 95 plus the 250, 250. So we'd have to take this amount here plus the 95%, 0, 5, 2 and 5 is 7. We would have to look up 9750. And so if we come down here and look up for 9750, you'll see, whoops, you can't see, table's too far down. You'll see that we can find the 9750 at 1.9, and then if you'll take my word for it that it is in the 6th column. I think you can see that. And so that will give us a positive and a negative 1.96 for the corresponding z-scores. Again, we want to indicate what our answers are. Again, doing it on the calculator. Second, distribution, number 3, 0.025. And this time I'm going to leave off there. Now notice this time, again, the calculator doesn't have a brain, so it doesn't know to round it. So you'll have to know to round it to negative 1.96. So again, that's why you look here and say 1.95. Then you want to go back to your chart, negative 1.9. Then come over to your 5 and say, oh, I need to be, yep, that's the one I need to use, 1.96. We want to round it to the 2 places. Then if we wanted to find the other one, we do have to do the addition, just like we did here, and do inverse norm. Again, second, distribution. Whoops, I keep hitting clear. Second, distribution. Number 3, inverse norm, 0.975. Or you can put the 0 there and get the positive 1.596. And again, check it with the chart, 1.96. And it's under the 6th column. Well, I hope this helps you with the standard normal. You also probably want to watch the next one where we do the ones that are not the standard normal, but the regular normal charts. If you need any additional help, come by and see me in room 222 of the Math and Behavioral Social Science building. My name is Beth Dixon.